Thank you, honey bunny. Right now, take care of yourself. Okay, I'm going to go over into the other chair here. We can check everything. Started a little earlier. Usual to give us time. So, video, audio check, everybody. How's it doing? Uh, that'd be pretty funny, honey bunny. Oh, so audio, visual check, doing okay? Actually works pretty good when I look at the uh, comments. I'm also looking pretty close to the camera. Hey, Dave, how's it going? Oh, how much snow you got over there at Butte? We don't have a lot over here, but it's staying pretty well. Hopefully, it's not going to be too snowy tomorrow, but right now we've got Eva's stuff in the afternoons, so it shouldn't be too much trouble. You don't have to do any blood tests tomorrow, do you? Only on Mondays? Yeah. Okay. Yep. Yeah. Thank you, Chain. Thank you, Dave. Yeah. It's my little minivan actually does pretty good in the snow. I'm really happy with it. Uh, Eva went and got her first radiation treatment today, and another. It's kind of like chemo, but it's not as not generally as rough as regular chemo. It's immunotherapy instead. Okay. Hey, Brian. So anyhow, she's conscious on the couch right now. It's not like last week, and I do appreciate your help last week, Brian. Thank you. So much Darwin this morning. Can you elucidate a little bit, Shane? I'm not sure exactly what particular thing you're referring to. Anyhow, um, right now I'm uh, got my test results, and it showed some interesting things. And oh, that wasn't full. And so I'll go over them. I've also got some spot tests that are indicative, but not necessarily definitive in any way, shape, or form. So, um, first thing, we've decided to go with the max water resin. Okay. Um, it recovers as gold as well out of solution as the Eco Goldex. We know it's strippable with the acid thiourea. Even the Eco Goldex resin didn't like the Eco Goldex stripping solution. We only got like 30% recovery. Both resins tentatively appear to have a kind of a limitation in terms of how low they can strip out of solution. I've got some more samples that I sent over this morning. Well, took over this morning. Um, but it seems like both of them take it down to about 4 parts per million. I did the resin in solution test. This was to really get rid of variables. I had solution, knew how much was in it, run it, and whatever happens, happens. You don't have any ore or anything like that that can keep complicating stuff. The solution started out at 21.8 parts per million. The max water resin took it down to 4.02 parts per million, and the Eco Goldex resin took it down to 3.97. So only 0.05 parts per million difference. That's pretty, pretty close performance there. The max water resin may or may not be a little bit more expensive. I'm not sure. But the attrition tests we did last week show definitely a lot less attrition with the Eco Goldex, and that'll very quickly pay for itself, so to speak. We still don't know how to regenerate it, but I haven't tried regenerating the Eco Goldex resin either. We've tried regenerating the max water. So far, not much success, but considering it holds 100 times the gold as the cost of the resin itself, not a big issue. So are we guys like engineers? No. An engineer has a degree. I'm basically an intelligent miner that's very curious. And therefore, I learn a lot about a lot of different things, but I am not an engineer. I am not a chemist. I am not a geologist. Okay? Hi, Jimmy. How's it going? Not at this point, Jimmy. I hope everything's going well for you. We're getting by over here okay. Hope the little babies are doing just fine. So, that, hey, Mr. Virtue. So, I do a lot of stuff empirically, i.e., I just try it and see how it works. I know enough to kind of fine tune stuff a little bit, but I'm not knowledgeable enough to where I can just sit there and go, okay, if I do this, this is what's going to happen. No. When it comes to that, I'm more knowledgeable as mining and heavy earth moving than I am in chemistry. Okay. Hey, David. So, the resin in pulp method has the advantage of being technically very simple, and it's easy to get the gold away from the pulp. You just screen out the resin. The problem with it is attrition. 9% losses with the max water, 17% with the Eco Goldex. That's bad news. Not horrible news, but not good news. So I was testing to see what I could do to kind of minimize that, because you can bottle roll, agitation, leach, or whatever as much as you want without the resin in it, and you're not going to get any attrition. So if you leached it to the point where you've done everything that's going to happen, then put in the resin, now all you have to do is just keep the resin surrounded by pretty good chemistry. So I tried an experiment. Here's one of our bottle roll bottles. Okay. Now, first of all, explain a few little modifications I've made to this thing. Number one, see this black stripe right here? Okay. That's where it wears on the roller. This is pretty thin. Let's see if I can show it to you. It's pretty thin material. Okay. So it doesn't take much wear to wear right through this and make it useless. Okay. So the white that you see is just electrical tape. Okay. I'd don't seem to be having a problem here, Jeff. Is anyone else having problem um, with the with buffering or whatever? I presume there's a couple of reasons we can get losses in the resin. By the way, this is one of the actual bottles that I used. So the resin in there is still doing its little thing. I use the tape as wear plate, basically. It's a wear surface, easily replaceable. The other thing you'll notice is the lid is blue. They come white. It's blue with a black edge. See, there's the color it should be. What I do is I put blue electrical tape on it. I mean, blue masking tape. Wrap it in electrical tape so it doesn't come loose or whatever. And 104.133 is not available at this time. Well, that's not good. Anyhow, right there is a hole. It's just a small little hole. This is a vent hole. So that when it's rolling, you can see the level of slurry is much lower. Ah, come on, tighten up. That wasn't good for my calculator, I'm sure. Anyhow, as it rolls, that doesn't get anywhere near that vent hole. The reason I need the vent hole is when I'm putting in hydrogen peroxide or some other stuff, I get effervescence. I generate gas. And therefore, these things could blow up if I didn't provide some venting. So those are the modifications I make to use. Okay? Hey, buenas tardes, Rock Butcher. So that's what I've done to the bottles to make them more durable and to be able to handle effervescence. But what I did was after I got the, I'd run it through the agitation the agitation leach. I put the resin in because there was 3 bottles from the last test I did that were just agitation leach. Okay. One was hydrogen peroxide Eco Goldex O. One was hydrogen peroxide Eco Goldex S, and one was hydrogen peroxide Eco Goldex O backup. I've had one time where one of these lids, I didn't get it screwed on tight or whatever, and I lost the whole test, and it's like, now I have to start all over again. So I had just a backup. But anyhow, what I did was I put one bottle on the bottle roll. I had another bottle, which, according to the lab results, was basically exactly the same solution concentration. Put it on the countertop. And all I did was set the timer for 4 hours. While the one was bottle rolling, I just took this and just shook it like that. Once every 15 minutes. That was it. Okay? Because that's going to get a lot less grinding of the resin. Now, here, this line of spots here, this was the spot test of the solution before the bottle roll with resin. Okay? As you can see, each bottle had pretty similar amounts and pretty strong. Okay? Then I did the middle one was the bottle roll. This was the intermittent agitation. That was intermittent agitation. I cannot be certain that these spot tests are accurately depicting the gold. There may be other stuff, don't know, can't be sure, but this is what I got for now. These samples are off at the lab for confirmation. But as you can see, they went from, let's see how well I can do this here. They went from this, see that row there, to this in 4 hours. Okay? Looks to me like something is definitely, hey Sarah, was definitely being removed. The other interesting thing is it looks like it was being removed damn near equally. If anything, the number 2 looks a little bit darker. But this indicates to me a high probability that intermittent agitation will be relatively as effective as continuous agitation. But let's time this. 1, 2, 3. 3 seconds out of every 15 minutes is definitely going to do a lot less grinding of the resin. Now, after the live stream tonight, I'm going in there and I've got those 3 bottles and I'm going to be taking the resin out of them and then weighing it and seeing if I can detect a difference in the weight of the resin. I wouldn't be surprised if I can't, simply because it's going to be relatively small. And the resin itself, it has a moisture content issue with it. You know, when you weigh it, it's pretty variable on how long you've let it drip dry and whether you've shaken it or just let it sit there. So I would assume that it's going to be fairly similar no matter what. If anything is less, it should be the number 2 canister, number 2 bottle. But it would, but first of all, it's hard to get a paint can shaker that'll do 100 pounds. The most important thing is you want it to be just agitated and then stop. So you want something you can start and stop. My thought is if you have an electric cement mixer, real easy to set up a timer. You know, run it like 1 minute. That's probably the lowest increment you can get. Might have to get a special timer, like 1 minute out of every 15. Okay? So that it will start up, run for a minute, shut down. That would definitely decrease the wear. Now, another thing we can do, I took the Max Water resin and I screened it through a 30 mesh screen. I got about 5 to 10% passing a 30 mesh screen. Now, obviously, that 30 mesh, you know, I'm doing the previous test, these tests with a 60. But obviously, if you screen it to a larger particle size, then it's going to take more abrasion before it can get through. So that'll improve your overall recovery. By using less agitation, you should improve recovery. By using a smaller final screen, you ought to be able to improve recovery. I was just using a 60 mesh screen. We could theoretically go to a 100 mesh screen because all of the stuff at the mill is going through a 100 mesh screen. So if you were to pre-screen the slurry, you know, after it's been concentrated and stuff, just pre-screen that through a 100 mesh screen and then do the rest. And the other thing is, the plan is to take the sulfide cons, throw them in a little mini ball mill that they have with hydrogen peroxide and run it for like an hour or two. Does 2 things. The hydrogen peroxide is going to be reacting with the sulfides and oxidizing them, but also the balls are going to just be beating the bejesus out of it. And so if you started with 100 mesh minus, you might wind up with 200 or 300 mesh minus. Okay? And it might very well work. Kodak but it would be pretty complicated to do. Say this is not something I'm not trying to do this for production. This is purely for testing. So it wasn't needed to get the information that I needed. I think that's what I better. So anyhow, it was just as a test to see what it doesn't foam very much either way. When you put the hydrogen peroxide, it effervesces, but the bubbles pop easily, as opposed to making an actual anywhere near stable foam. But you can definitely see the hydrogen peroxide is doing something when you first start putting it in. You betcha. It really is effervescing, not violently, but vigorously. Okay? I mean, it's not subtle in the slightest. Now, another thing that's interesting with this plate here is these 3 columns here were another test. 3 different bottles, bottle 1, 2, and 3. And I tried different things because I have seen recoveries from the solids vary anywhere from about 80 parts per million to almost 300 parts per million due to factors which are not clear at this point. Okay? You could probably do that, Kodak. I don't know how. I'm sure it could be done. Okay? So, what I did was, with these 3 bottles here, first I took a known sample, I think it was 200 grams of material, and I put in 125 milliliters of hydrogen peroxide and 50 milliliters of water. And I ran it for an hour and a half. Then I threw in another 25 milliliters of hydrogen peroxide, ran it another hour and a half. They were all the little dipsticks, showed less than 1 part per million hydrogen peroxide. Okay, at that point. So it used up. I was only using 3% hydrogen peroxide. That's easy to get right here. But anyhow, so I did that. Then I added 10 grams of Eco Gold XO to each one. Okay. And then what I did, because again, I'm trying to figure out why this huge variation in recoveries. Something's different. When I do the same thing, I get the same numbers, which means it's not sample variation. If they were all over the place, yeah, I'd say sample variation. But if I do the same thing, I get the same thing. The thing is, when I try different things, sometimes it gets a lot better than other times. So I'm trying to figure out exactly what it is. Okay. Is it Eco Gold X? Is it the solids to liquids ratio? Is it the amount of pre-treatment? So with these, I was using a 1-to-1 salt, 1-to-1. I might only put in 100 grams. I'd have to look at my notes. They're in the other room. But anyhow, it's either a 1-to-1 or a 2-to-1 solid to liquids ratio. Not sure. Okay. But anyhow, what I was doing here was nothing. Once I put the Eco Gold X in there, I just let that one roll. This one here, I was adding 5 cc's of hydrogen peroxide every hour. Was it every hour or every 30 minutes? I think it was every hour. Pretty sure it was every. Okay. And then this one down here, I was adding a 0.5 gram of Eco Gold X every hour. Okay. And by doing that, I can see what kind of difference I get. Now, I don't know about you. I don't see a whole lot of difference vertically until I get to the last things. And that's, yeah, this one here is the last of that series. But the first two at 12 and 24 hours, I don't see hardly any difference at all. It's certainly not a big difference. But then at the 48 hours, I start seeing some differences between samples, but also differences between that and the 24-hour sample. So it is my assumption that time is a very important variable here. That it's taking longer than 24 hours in many cases to get efficient recovery. Now, if that's the problem, that's pretty easy to solve. You just run it longer. If you need a longer retention time, buy another cement mixer or two. How many days do you need? But that's a simpler problem in the long run than chemicals. Right now, to get good recoveries in the testing, I'm running about 25% chemical cost. Okay, that's a lot of money. Not only that, but the Eco Goldex, even though it's relatively non-toxic, nevertheless, this particular test was running, I believe, 10%. 10% Eco Goldex. For every 10 grams of ore, what? Okay. Okay. Okay, Brian, start giving me those 15-minute reminders again. Okay? So anyhow, I say I'm really giving it hell when it comes to the Eco Goldex. Now, I have the capability to titrate the Eco Goldex concentration according to the manufacturer's instructions. I.e., I'm using silver nitrate solution as a titrant, and what is it? Something ene as a it's a yellow chemical as the indicator. Okay, but I'm not sure exactly what I'm titrating. Am I titrating free cyanide? Am I titrating ferrocyanide ions? I'm not sure. It's the same chemicals as if I was titrating cyanide. Okay. Now, when we were out at the mill, I believe we were running 6 pounds of Eco Goldex per ton of solution, which was pretty good. Seemed to work pretty well. And that was 1.5 cc's. When we titrated a 10 cc sample, it should take 1.5 cc's of silver nitrate solution to reach endpoint. Over there, the residual Eco Goldex that I'm titrating, minimum was 16, not 16, 1.6, but 16.0 cc. So in the neighborhood of 10 times what we were using before, 60 pounds per ton. Okay. So we're really putting a whole lot more Eco Goldex into this than I would like to, both for cost and safety reasons. Because if you do get some acid in there, it is going to make hydrogen cyanide. Okay. So I want to see if I can reduce this Eco Goldex. It may be that by really pushing the Eco Goldex, you can increase the dissolution speed a modest amount. But if you just agitate it another day or two, you can get the same result with 1/10 of the Eco Gold X. Well, that's going to save, you're going to go from like 12% cost to, would that be 2% cost? Yeah, that's equivalent of 10% of your gold. What the heck? That's damn good. So, anyhow, this is what I'm focusing on at the moment. We've decided what resin we're going to use, we've decided what stripping solution we're going to use. We have a stripping circuit that seems to work just fine. It's fairly simple. Now we need to figure out exactly what the leach parameters are and also confirm how much resin to add per for every kilogram of sulfide cons. How much resin do you put in there? The industry standard would be about 20 grams. Okay, so these are the sort of things I'm trying to define right now. Hopefully after the first of the year, they'll have all the equipment down there, all the chemicals down there, and be ready to start going on. I need to make sure that they've got the data that they need and the parameters that they need. Now, another possibility that I have to check, where the heck is the, right, there it is. Okay. As your loading factor in the resin goes up, theoretically, there's some kind of equilibrium that is working here. So if you had twice as much gold in solution, you're going to tend to get twice as much gold in the resin, but you're never going to get all the gold out of solution and into the resin. So, happy birthday, Asakura. So a possibility is this too. Once you've leached the batch and you've dissolved all the gold in it, you add some resin, run it for a little while, then you take that resin out and put fresh resin in. Okay? So this gets loaded with high concentration solution, and this fresh resin gets low concentration solution. And then what happens is you move that to the next batch. Okay? So that you're kind of balancing the resin against the solution. When you're using resin and pulp on a small scale like this, it's pretty easy to screen out a kilogram of resin, and move it over here, In this case, if this is resin A, okay, this is resin B, okay, this would go to stripping. Then resin B, go to stripping, and like that. All you do is screen here, take it out, put the new stuff in, screen it, and like that. Shouldn't be too difficult to accomplish. I'll need to do some bottle rolls and screenings and stuff to see whether it makes sense. Don't know at this point. But the higher you can load the resin, all else being the same, the better. Especially since we're planning on using it once for now. So if we can get 2% resin loading as opposed to 1%, great. That means we're going to use overall half the resin. Okay. So, these are the sort of things that I'm working on now. And then this winter, once this is all routine and thoroughly understood, then I will go ahead and start doing other leach solutions to see if we can find something that works even better than the Eco Goldex. Yeah, it's yeah. On the other hand, look at what happened to JFK. Sometimes fame can be a problem, Rock. Does the resin completely drop the gold it collects? At the present time, it looks like about 95%, certainly more than 90%. However, the remaining gold could theoretically be recovered by ashing the resin. Okay. And whether you ash the resin and smelt it down, or whether you ash the resin and then just leach it, just throw it in with another batch of stuff. We should be able to get most of it back there. So you're definitely getting, the tests I'm running within the precision that I've got, I'm getting at least 90% of the gold that was in the resin. Okay. I got some good hints that it's more like 95%, but that's not too bad. And theoretically, you can get the other later by ashing. So, not a huge problem. If you could regenerate the resin effectively, which we have not yet been able to do, but which theoretically should be doable, then you just reuse the resin, and whatever is stuck in there just stays in there until such time as you ash the resin. So not a huge problem. But either way, it's a relatively controllable and easily absorbed loss. It's not a big issue. That's a lot better than 17% loss there. So that's the kind of stuff. The intermittent agitation seems to do pretty well. The hydrogen peroxide, I didn't seem to see a whole lot of difference by keeping the hydrogen peroxide, but I haven't really thoroughly examined how much hydrogen peroxide gets me how much gold. Although, while I was adding the hydrogen peroxide at 5 cc's per hour, the Eco Goldex concentration did not drop very much faster than the Eco Goldex concentration in the, call it, control bottle. Okay. So, it doesn't seem to be a big issue in terms of destroying the Eco Goldex. So it may, the question is, how much gold do you get for how much chemical cost, sort of thing. I go ahead and I'm going to do some tests on that to figure that out. Right now, it appears that with the limited data I have, about 1 cc per gram of 1 cc of 3% hydrogen peroxide per gram of solids is at the plateau, the maximum plateau. If you double that, it didn't change it. If you half that, it seemed to change it a little bit to the negative. Okay. Cool, Sakura. I had to stop it and put it in. Honey Bunny. Obviously, if you had like a cement mixer and a peristaltic pump, you could make a continuous flow if that was desirable. That was one thing I was looking at. Is this going to help me out? If it doesn't help me out, no sense worrying about it. But I say it didn't seem to do a whole heck of a lot of good. But it showed not bad. Say, did it do a lot of good? It seems to have had some positive impact. Again, we'll see when I actually get some assays back. Until I see these things, I'm a little skeptical. Oh, by the way, just as a little aside, just because you got a lab that you trust doesn't mean they're perfect. You may notice on this sheet, there's a little arrow there. That's because those numbers look really strange to me. Matter of fact, they look virtually impossible. Okay? Because how could the pregnant be 1/10 of the barren? So I went in to the lab itself with the guy and we looked at the bottles and the numbers had gotten confused. Okay? So those numbers were for the other bottles. So when you see something that is very odd, to say like, barren solution being 10 times more than the pregnant solution, you go, let me double check that. Okay. So, um, that's possible, but I have no way of monitoring the pressure or knowing what the burst value of these things is. I understand the possibility. Yeah. Assuming it's not going to blow up on you, you bet. Overpressure of oxygen, not going to hurt the thing. Assuming you need that oxidation potential, that'll work just fine. Okay. So anyhow, let's say, if you see something that looks crazy, don't be afraid to say, hey, that looks odd. Can you redo that? Sometimes the easiest thing for them to do is just redo it. They'll take the same sample and run it again. And if that's what had happened here, then when they ran it again, it would have gone, well, I still get the same numbers because they were mislabeled. Okay. When you give them these samples, you'll notice I've got weird numbers like HER5 Preg 24. Okay. They turn that into a serial number, so to speak. For example, HER5 Preg 24 is 7M395. And the next one, which was HER3 Baron 24, was 7M396. See, these are the numbers they use internally in the lab. They don't use mine because mine can be very confusing. So they actually write on the bottle a separate number. That's the one they use. If you send stuff to another lab, they might actually have like a barcode they put on it. Like when you go to the hospital, quite often they'll have a little sheet with a bunch of barcodes on it. They're all identical. That way, whenever they got a sample, they just peel one off and stick it on there to keep it straight. Yeah, I understand, Rock. Um, it's one of those things that, yeah, it can really screw you up. If it looks odd, don't be afraid to double check. Okay? And sometimes it's going to go, yeah, it all double checks and triple checks. Those are the numbers. Other times it's like, okay. So in this case, I was able to just go look at the bottles and see that the numbers that they put on there and that were correlated with this result were not the ones that I had, basically. They had been reversed. It happens. If I was perfect, I'd bitch, but I'm far from perfect. This lab does not have barcode. They just do it manually. you know. So for that reason, okay, let me check there, Brian. She's all right. Keep it coming, Brian. So anyhow, I'd say that can be very, very important. You can also have cross contamination. You can have a miscalibration or an issue. For example, we're using an ICP over here. It has a little capillary tube that sucks a sample and throws it into the machine. Probably not Rock Butcher. It's just a local water quality lab. Okay. Um, I I don't know the certifications and stuff, but anyhow, um, they meet certain certifications for water quality. I have no idea. I'm using them because they're local, inexpensive, and very easy to talk to. Plus, they give me surplus lab gear that they don't use anymore. But anyhow, uh, so there's all kinds of things that can cause a problem. And aside from mislabeling, I say a miscalibration, a plugged capillary tube, there's all sort of things which can totally screw things up. So if you see something and you go, that just doesn't look right, don't be afraid to ask, could you rerun that? Okay. Or could you double check your data? Because all these machines generate a bunch of data and put it in a memory that they can go back and look at. And there's been more than one time where we've done that, and he goes back and looks, says, okay, standards are showing good. Everything. I see nothing here that makes me think that it's an inaccurate result. Okay. And so, let's say there's inherently ways you can check these things. Okay. That's pretty funny, honey bunny. Uh, okay. Thank you, Jeff. Take care. So, that's an important thing. It's not common. But if it's one of those critical things, yeah, it can really throw you off, and then life sucks big time. You don't want to be wearing glasses that give you a distorted view. That can cause a problem. So anyhow, just thought I'd bring that up while I was at it, because I say that was one of those things that's like, that doesn't make any sense, you know. And depending on the situation, in my case, it's real easy to talk to the lab guy. I mean, I just walk back in the lab and chat with him. Not a problem. But how would the secretary know what was going on? If you're dealing with a company where different people do different things, and the secretary can double check stuff and say, well, as far as I can tell, those are accurate. Okay? So you might have to dig a little deeper. Don't be afraid to dig a little deeper. Hopefully, these spot tests are giving me actionable results. I don't know. By the way, these spot tests, instead of the usual half a milliliter per sample, 1 drop per sample. That's how concentrated it is compared to what it's designed for. Now, a drop is not a precise measurement. Okay. So, one should be aware. And there's going to be some variability there, But again, if you take a look at those three things, those are pretty damn close. So if it can give me actionable intelligence, and I mean, certainly here you can see something's changing, So I say, hopefully I can also get the spot test so that we can use it instead of laboratory assays for lots of things. Okay. For example, if this is running, say, these here near my finger, if those are running 200 parts per million, and that's running 20 parts per million, well, I tell you, you've done a pretty good job. And then you can keep doing an extraction and get even better. You can also add more solution instead of the one drop, go back to the half a cc. So you can do a lot of different things by changing the concentration. But say I'm not too worried about the resin and pulp. I got some things I can do to make that get, really minimize that attrition. Assuming these spot tests are probative, then I can really do a lot by just using intermittent agitation. What I'm really worried about is this one here, getting the primary leaching as efficient as possible, i.e. get as much gold as possible out with the minimum cost. And most of that cost is going to be in chemicals. You also run into the issue of supply. If you're using Eco Goldex, what happens if something interferes with the the supply of Eco Goldex? You know, you got a single source. 50 microliter. That sounds about right. 1/20th of a milliliter is what I was thinking. But anyhow, I say so. By having multiple sources is better, but you know, you don't want to be too dependent. You don't want to have too much money tied up in stuff if you can avoid it. I mean, if I can go down from 15 cc's titrant to 1.5 cc's of titrant, I just cut my Eco Goldex cost in by a factor of 10. Yeah. So let's say this is what I'm primarily working on right now, is what I'm focusing on. Hopefully, in the next week or two, Jared will come by for a day or so. I'll get him familiarized with the stripping circuit and maybe the fire assay. Again, just familiarization sort of stuff. So that he's more comfortable and knowledgeable when he goes back down to Central America. 1,000% efficiency. Yeah, I'm all for that. I also don't know for a fact that we may not be running into an equilibrium issue here, where once we get a certain amount of gold in solution, then it starts significantly suppressing the dissolution rate. So we may want to throw some resin in there too. You take care, Rock. Keep it safe up there. But say it may be that we can increase the recovery rate by doing a resin and leach after a certain point, and we'll actually grab more gold than was in the leach solution when we threw in the resin. Okay? That's entirely possible. As a matter of fact, it's fairly plausible. The question is how much. And does it leach anywhere near as well using limited agitation as the recovery works. Simply don't know. Um, that's my job. Get all this stuff tested. Keeps my mind occupied when things are slow and I got other stuff that I really prefer not to think about. You know? So um, that's kind of what's going on here. And I think I'm making good progress. I have not achieved complete understanding of this system, but I think I'm getting to the point now where I can really start refining it, especially if I can get these things to work. Spot tests, it'll make it go a whole lot faster. Yeah, exactly, James. I'm wondering what's going to happen. If are they going to hit a squeeze where all of a sudden they've got all these contracts out there that people want their silver and they can't supply it? So that could really get real interesting. Yeah, it was up to 59 today, somewhere in there. Oh yeah, it's doing well. So's gold, but not as well as silver on a percentage basis. And the international situation continues to be unpredictable. The domestic situation continues to be unpredictable. The global economic situation continues to be unpredictable. I don't see any reason why it's going to calm down anytime. So, I say, we shall see what we shall see. I haven't tried doing anything on that right now, but we might do something this winter. Again, we shall see. I'm kind of free forming it this winter for obvious reasons. We shall see what we shall see. Uh, so I say that's basically what's going on at the moment. The gentlemen from Central America are they're not communicating as well as they were before because they've got families and it's the holiday season and stuff. So they can't focus on business like they would normally. I understand that, and you know that's fine. You know, but like I say they're just not as focused at the moment as they normally were. And you know, going from here to there. Anyone got any questions or subjects or anything you want to bring up? Okay. Yep, she's okay. But I say that's what's going on at the moment. Uh, Alpine Analytical is making a lot of money off of us. The, yep, there's $250 right there. uh, I dropped that same number of samples off this morning. Hey Lars, I don't believe so. Lars, I don't think it's conductive enough. Yeah, the ions wouldn't be very mobile in that, Lars. Uh, but anyhow, we say we're making progress, getting it whipped into shape, and hopefully by the end of January, they're pretty much routinely going to be recovering a fair amount of gold from the sulfide cons. Really, Lars? Wow, you Californicators are really way behind the curve. They're pretty good, aren't they? Here's an advanced technique: peanut butter and honey. So, how's things going down there in the charred Southlands? Things getting back under control, or is it still pretty chaotic? Uh, so anyhow, I say that's what's happening here. Um, so far Eve is doing okay. It's going to be about 2 weeks before the rubber meets the road, so to speak. We'll go from there. Blackstrap molasses. I like peanut butter and sugar would work. Again, I prefer honey, but oh well. To each their own. There is no arguing. Hey, it just is. Um, I keep you guys informed. If you got any questions or whatever, you can always ask, and we'll uh, see what we can do to help out. I got communication with Jeff Kablock a couple days ago, and yeah, he's planning on being ready to rock and roll this summer up there, 35 miles away, 35, 40 miles away. What, little one? Hold on. Okay. The goddess wants me to remind everyone that silver has doubled in price in 1 year, but it's still good to back up a truck. Okay. Um, but so we should have a lot of interesting stuff this summer too, assuming the world don't end, and that could get quite interesting. Yeah, he's right now he's getting everything packed up for the move and this and that. I presume he won't try and move up here until like April because it's still getting colder right now. We just got the first time the snow really stuck on the ground for any length of time. I have no idea what it is temperature wise out there, probably in the neighborhood of 15 or 20. Um, but we still got another month before it really starts getting cold. The end of January is usually when it starts. I mean, where it'll stay at or below zero for a week at a time. So, I say I'd be surprised if we tried to move up here before April. I have no clue, Mr. Virtue. So, anyhow, I say that's what's going on. A guy named Jeff Kablock has a number of mines uh, yonder, about probably 35 miles, maybe 40 miles away, and he'd like us to kind of help him out this summer. And sounds like a good time. He's got some hard rock, he's got some placer, and should be some interesting stuff. So we shall see what happens. But he's apparently got some pretty good ore, And all the stuff that I'm learning now is going to help me in other places too. What kind? Gold and silver. I'm sure the placer is just gold, but the hard rock. He's also got some that's got significant uh, value in silver, like 200 ounces or something. So pretty good. I know someone else who found some stuff locally that was yeah 65% copper, 5 ounces to the ton silver, 5 ounces to the ton gold. That's useful. Definitely useful. Yeah, I understand, honey. I was hoping to be up there this summer working with him some, but that just he had some delays and such and wasn't able to make it. I think he had trouble finding a place to stay. Finding a house to rent or something to that effect. Get exactly what it was. He had a complication. The year before, it was his father got very ill. Oh, that's right. Eva just yelled out at me. Yeah, he was waiting for a well to get put in. He couldn't get the well drillers to get a well put in. So can't live too much without water. Um, but anyhow, yeah, it should be very interesting summer. Um, this winter ought to be interesting because I should be learning a whole lot about leaching various solutions. Hopefully, I'll have this pretty well whipped into shape in less than a month. Then I'll have another 3 or 4 months. I can focus on other leaching solutions. Yeah, there's probably going to be a lot of that, honey bunny. With the price, yeah, we got another rush going on. Nothing new there. But we shall see what we shall see. Uh, see how good my physical condition is, too. Still a bit short of breath at times for unknown reasons. So we'll see if we can get that figured out and fixed up. Got to get Eva uh, fixed up and healed up. So yeah, we got a busy winter, although it's not going to be so much field work. We got a lot of lab work, which is good. I agree, honey bunny. Saw the same thing happen back in the 80s. But hey, that's where we're at right now. That's the weekly report. Any questions or subjects or anything at this point? Uh, I still got some testing to do tonight. See what happens. I got 3 of these bottles to strain through some screens, recover the resin, weigh it, and then dry it out so I can start assaying tomorrow. There's Eva.
Hi, everybody.
Anyhow, I guess we'll call it a night. Okay, how do I end the stream there? Same place where I started streaming, just hit stop streaming. Okay, honey bunny, cue
And
it
then a
up.
little while box will come up, so you store and press it.
Okay, so go ahead and type it in.
Hi,
There.
wage slave. Hi, honey bunny. Hi, Mr. Virtue.
No, she looked the other way. She was looking the wrong way at the time.
Hi, Lars.
So everybody, thanks for showing up.
Happy prospecting and
Hopefully
keep
we've
it
been
safe
helpful.
out there.
Yep. What she said.
Bye, silver and gold.